2. Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's Security Boulevard webinar, Securing Your Development Infrastructure and Apps from Supply Chain Attacks, brought to you by Argon Security. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to access the recording for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit securityboulevard.com/webinars. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. Finally, stick around until the end because we are doing a drawing for $425 Amazon gift cards, so stay tuned to see if you're a winner. And finally, joining me today is Eran Orzel, Chief Revenue Officer, Argon Security, and Joseph Elbaz, Head of Application Security, Grubhub. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
All right. Thank you, Julio. So hi, everyone. My name is Eran. I'm running the business side at Argon, and a little bit about us. Started a year ago, we're providing holistic security for the software supply chain. We're going to talk a lot about it during this session and show you how you can get, visibility, insight, security enforcement, and release integrity to your software supply chain. Joseph?
Hey, my name is Joseph. You can just call me Yossi. My nickname, like the Israeli nickname. Basically working at Grubhub. Started as a application security lead, was application security head of Tel Aviv office, and currently it's expanding, and I'm leading most of the global projects of Grubhub regarding application security. So basically, a few words about Grubhub. If you guys are from United States, you don't really need an introduction to Grubhub. But few buzzwords, like we're talking about $9 billion gross of food being sold in 2020. Our daily average is a bit more than 750,000 orders. And one of the things that I think that's worth to mention here is that basically Grubhub not just doing food delivery and food ordering, and we also like have a few other advanced services in the restaurant world, which part of them like basically it's in-store equipment and cashier line, like KDSs and many other in-store equipment.
Excellent. Thank you, Joseph. So what we're going to talk about today is trying to really dive into the modern software supply chain. We talk about the risk, the enterprise challenges that we see with your peers. We also cover how to secure the software supply chain. We'll talk about the theory, the framework, but also practical, let's say, solutions or processes that will help you take control over the software supply chain. We will have Yossi here talking about how he built his AppSec program at Grubhub and how he's building a strong security as part of their delivery process. And at the end, if we'll have time, we will do some Q&A. I'll try to speed things up and hopefully we'll get there. So let's start with the modern software supply chain, understand the risks and why we are spending the time here to show you how to protect it. Now, when we talk about the software supply chain, basically we are talking about a process that starts when a developer commits his code or his file to the source code management of the company, all through the build, test, and deployment process until the application is running in production or until this update is deployed. Today, we see more than 90% of the companies using those automatic CI/CD pipelines. CI is more common. CD sometimes is a little bit more manual. And when we talk with security teams around the world, it seems like this specific area is the weakest surface in enterprise security. And the main reasons are the process itself. The process is built for speed, automation, collaboration. The tools, most of them don't have strong security feature. And by that, they are opening the organization to risks. The reason it is so important to protect this process is that now, when everyone is moving to the cloud and everything is application or cloud service, the software supply chain is becoming the core component in the development process. Also, it is very strongly tied to the production environment and basically used for cloud infrastructure configuration. Also, on the supply chain, you will find credential for the various system and environment as an environment variable. And as we talked already, since it's a very quick and automated process, without protecting it, you basically expose your application and you don't have real visibility to know if it's being attacked or not. Now, when we try to understand what are the main vectors that contribute to that, and it's important because we will use it to try to solve the issue. The first one is the complexity of the process. Usually there are dozens of systems, tools, and services that participate in the software supply chain process. Some of them can be the tools themselves, like GitHub, Jenkins, Docker Hub, Bitbucket, and others. Some of them are services that connect to it, like Kotkov, Jira, Monday, and others. And all in all, it's a very complex and dynamic process. The second part is that everything that is being done on the pipeline, every configuration file or script is being written by the local development team, meaning that there are many places that errors or misconfiguration can happen. And this is something the attackers are looking for in order to exploit. And the last thing is basically we see that in most organizations there is very little cooperation between the development and the security teams when it comes to securing the supply chain. And this is basically create a situation where either it is not protected at all or there is very little security, and we will talk about it over this session. Looking outside and what we've seen in the last 12 months, we see that the threat is getting bigger. The number of attack is growing dramatically. It's just, if you can see here, 4 times on average from 2020. And if we look at one of the popular attack vectors, the poisoning of open source packages, you see that it's like 7 times almost, 650% growth since last year. And what we can learn from analyzing all those attacks, that the current traditional security tools are not able to block such attacks because they are protecting different vectors and different areas, and we will show it to you over the next couple of slides. So when we talk about the software supply chain and the various stages, and this is just a high-level illustration of it, you can see that there are many attack vectors and lines of attacks that the attacker can take, starting from malicious code upload, compromising the various tools and services. It can be even your dependencies, trying to tamper the build process, the connectivity, the packages that you upload, also your artifacts. And the idea is that the corporates or the organization, the software developing organizations, are facing multiple attack vectors, in many cases simultaneously. And if we move to the enterprise challenges, there are a couple of things that really delay their ability or slow their ability to react in good time to those new attack vectors. The first thing that I covered is the number of attack vectors, the increase in numbers of attacks. So this is a growing risk that is growing almost exponentially. And we're talking about a security team that most of them don't have the knowledge, the expertise, and the understanding of those complex development environment and exactly how to embed security in them. The second part is the complexity of this environment. Many tools and services that expose it. The process is very dynamic, very fast, changing all the time. And it is not under the realm of the security team. Usually, the DevOps and the development organization is running it. They have the access. They are doing all those activities with very little visibility. And the third item, which is like, I think it's generic in the industry, is the lack of resources overall in security today. So most AppSec teams are understaffed. They have overwhelming load of work. And in many cases, also lack the budget to really secure the process properly. And I assume, and we can ask Joe in a second, but like any other area in security, there are dozens of different tools and a lot of complexity there. And those guys really have a big issue and also need to deal with the application in production, in development. So a complex task ahead of them. And a question for you, Joseph, is can you share with us your challenges in building your AppSec security? How did you actually thought about it, and what did you do to secure your supply chain in light of those items?
What do we do? I think that it's supposed to be in the next slides, but well, we have a lot of challenges, of course. The first one that you also mentioned before is like the lack of resources. And when talking about lack of resources, basically, I think like any organization of today have lack of resources, not only on the security side, also in the development teams and DevOps teams. These teams are always occupied all the time, have time for nothing, and the business keep pushing and keep sending tasks. Which means that first, the priority of security usually being pushed aside, and we need to work really hard to prove why we need security and what exactly is security. And from the other side, we also need the resources, and these resources usually dedicated to the business first. And from the other side, the security teams themselves are usually small teams and without enough resources. Basically, like you mentioned in the previous slides, when we're talking about environment, very dynamic environment that we cannot slow down and tell them, okay, guys, hold on, this is what you're trying to push to production right now. We need to analyze everything and put everything on hold till we have a clearance or till we verify that everything is okay. It's not something that can be acceptable today. Like if you're looking at 6-7 years ago even, when more or less the only application security concept was WAF, was the end of it this time. Then we actually approved, like we used to work in some kind of let's call it positive security mode, and basically every new change in the application, every new version, whatever going up, we need to go through security approval, talking about manual approval and teaching the WAF, or basically configuring the WAF to not block the new version or the new code that's been released. In this world of today, this cannot happening anymore. It cannot be happening anymore. And security all the time is chasing after the business and trying to catch the gaps, which is completely difficult. And can keep talking about that. And the question is, how long do we have to talk about it?
We will have time after, so maybe we can cover it when you talk about how you dealt with the issue, so we can highlight a little bit about that.
I think I want to add something small here, and basically you also mentioned it before. as security people, we can always analyze, scan, do whatever we want behind the scene. But when it comes to fixing things, we totally depend on the other teams, like if it's DevOps, if it's the developer teams. Basically, we are not the one that's supposed to get into the code and start fixing things like, I don't know, SQL injections findings. The only thing that we can do is to verify the finding. And one of the main issues there is to get these teams on board. So,
Okay.
go ahead.
Thank you. So now that we understand the issue, we're going to spend some time talking about how you can secure your software supply chain. And I think one of the things that is very important, like any other security area, in order to really build an effective security, you have to cover the entire process. So we're spending a lot of money and effort to secure the runtime of the applications, securing the cloud, securing the container environment, looking at the application. If we want to make sure that it's running as planned, we need to also invest a lot of effort in the software supply chain that build it and try to eliminate as much issues as possible in order to minimize the effort to fix it when it's run in the production. And like Joe said, basically every time that we find something, no matter what, we need a development organization to fix it, send an update. This is a process that takes a lot of time and effort and take them out of their daily job. So as we do it as early as possible, we can fix it before it release when they are working on this process. So the fix time will be minimal. The second thing is that you want to do two things here. Cover the entire attack surface, meaning that you saw that there are many vectors here, and if we just cover very strongly one of the vectors, meaning, okay, let's take open source packages and we, build security around that. There's going to be some vulnerability exposed in one of the services that connect to your pipeline or one of your dependencies to the pipeline tools themselves. And from that, you can get even a worse attack than a package. So in order to feel that you're covering in a holistic way, you need to provide a solution to all those attack vectors at once. And as we already saw, build something that you can really manage. So get the maximum security with the minimum resources that you currently have. And the last thing, and this is I'm going back to what Joseph already covered, if you want to be effective in that, you need to make sure that you're not making any compromises on the development process and speed. Because at the end of the day, the business lead the way, and it's once the developers understand that applying your security tool will start delaying their builds, start delaying their release, they will just not use it. So those are critical items that we need to take into consideration. And now I'm basically going to talk a little bit about Argon and what we did. So you can see in front of you the Argon Software Supply Chain Security Framework. Basically, this framework is built based on analysis of the attack surface, deep understanding of security and the development tools, and a lot of work that is being done as part of developing the industry standards. So we are part of the Cloud Native Foundations, and we're working with them, with CIS as well, to build the security standard for the CI/CD pipelines. We also looking very closely at the Google Salsa project and making sure that those high-level guidelines that they are releasing on a secure code development will be implemented as practical, let's say, practical best practices as part of the Argon platform. And the idea here is that if we look at those enforcement points that included in our platform, we are able to provide you with source code integrity, build integrity, and deployment integrity, and basically covering the process start to finish, doing it in a way that enable you to prevent commit of malicious code and file to the pipeline, securing the pipeline tool, either the source code management, the build, the Artifactory, understanding and analyzing the pipeline files themselves to learn the process. And this is a unique scanner that we have that basically map the process itself, check everything where it's coming from, and make sure that it's according to your policy. Putting a lot of focus on the dependency that you have in the pipeline, making sure that those tools are not accessing areas that they cannot, are not echoing or printing information outside your pipeline. Artifact integrity, this is today running in beta. This is our SBOM manifest. Basically, we took the SBOM and added on top of it. SBOM is the software bill of material. This is like something that is starting to be pushed down from the US government, making sure that every artifact, every release, you can get the manifest with all the components that are in it. So in case something is vulnerable, you will know. So we are adding on top of this a list of security and DevOps checks, and basically enabling you to build a gate that will check that and make sure that you are releasing only artifact with high security and quality. And of course, securing the Artifactory and making sure that we enable you to release only trusted packages. The way that we are doing it is basically we are connecting to your CI/CD pipeline tools and applying 3 layers of security. The first layer is securing the infrastructure. And by that, what we're doing is applying policies over the tools dealing with misconfiguration and vulnerabilities in the CI/CD pipeline tools, in the dependency that connect to them, and in the networking of the pipeline. And by doing that, we are creating a much or basically starting and hardening process over your the CI/CD pipeline infrastructure. The second part is the process itself. And here we are applying security and DevOps best practices over the process. It being enforced on every activity that people will do on the pipeline tools. It is also going to scan all the pipeline files and configuration scripts and make sure that they are running according to policy, running all the various checks that you want them to run, making sure that they are not exposing you to anything and not applying any new dependencies that are not approved and so forth. The third layer, which is the most popular layer today, is the complementary security scans. And here we took like an approach that is aimed to help the customer maximize their ROI. So we have, as part of our platform, a universal scanner that can enable you to use it to scan for secret infrastructure as code, open source packages, and many other types of tools like SAST, and we also scan the pipeline file themselves and so forth. But our system can also enable you to orchestrate other scanners that you have, either from the development time or from the runtime. And basically, if you are running a solution that scan, I don't know, containers in real time, we can tap and apply and enforce those scanners as part of the pipeline in the build process, making sure that we're not packaging any vulnerable or misconfigured container as part of our artifact. And we are able to help customer pick and choose what scanners and what type of security they want to apply. And the strategy behind all that is really based on the understanding that security teams are starting very late. If you look at the amount of attacks that happened in the last 12 months, there are hundreds of attacks I can cover, and a lot of them are successful because the organization today don't have strong security over the pipeline. So in order to help them bridge this gap very quickly, we build our solution as a way to immediately apply strong security over those three layers and close tight the software supply chain process. And the idea here is to provide you unified visibility and control across the process and make sure that the infrastructure itself is strong and can defend against supply chain attacks, like we see, for example, in the SolarWind case. We also look at the enforcement of security practices and making sure that no matter what scanner you use or what else you want to connect to it, we're going to apply dozens of best practices, policies, and let you together, the security and DevOps team, build a strong policy and enforce it in a very easy way. And at the end, really provide orchestration and governance over all those scans and making sure that through the process, we improve the code quality and the code security and minimize issues in production, because when you're in production, everything is more expensive, everything is a bigger effort, and you want to not go there. Now, Joe, maybe so we talked a little bit about Argon and what we highlight as our benefit. I think maybe the audience will be interested to hear about your experience when you started to think about which tools you want to add to your AppSec stack. What were the things that you were paying most attention to in terms of the tools you choose?
Well, it started by creating more or less the areas that I want to cover, and in the process, one of the things that you're realizing is like as long as the technology becoming more advanced and more complex, you need more and more tools, right? Like if in the past, like secret detection, dependency checks, and static code analysis were enough for the process of building securing the code and scanning the code. When we're looking now at all of the flow of the CI/CD, we have a few more layers there, right? Everything that's related to Kubernetes, infrastructure as code, the containers themselves, the config of the containers, and etc. and etc. and etc. And one of the things that you immediately realize that the same team that before used to manage 2, 3, maximum 4 tools, now need to start managing 6 or 7 tools, right? And one of the things that you immediately understand is that okay, come on, I have 6 or 7 different vendors, 6 or 7 different approaches to how to manage these tools, and everything becoming complex. You basically need to have a PhD for each one of these tools to actually operate them really good. And then is the time that you're starting to look how to simplify things, how to make your life easier. And it's not really easier, right? It's like how to make yourself not fail, because you have too many tools, you have too many things to deal with, and a bunch of reports to deal with. And basically, one of the things that you're looking for is let's say multiple purposes tools. Basically, this is more or less how we got to Argon, right? Since Argon basically covering all this area, so more or less this is what we're looking for, mainly to simplify everything and make sure that we can actually manage everything.
Okay, great, and I think that over the last slides we highlighted that it's some of the advantages that we want to bring to the table, enabling organization to use Argon as a visibility tool, as something that will give you governance over everything and the ability to understand what's going on. And if you feel that there are more things that you want to add on top of that, we can help orchestrate it. But the idea is, and we see it with a lot of companies that are just starting, we can be the cornerstone of your AppSec strategy and really help you go from, I don't know, 0 or 20% to 90%, and then you can fine tune and do what you want to do. And now I'm going to give the control to Joseph to talk a little bit about, how he built his AppSec program. Tell us a little bit about the Grubhub story, and I'm sure that once you see that, there's many lessons or ideas or things that probably you can implement regardless of the tools that you want to choose. So please, Joe.
Right. So basically, I think like we can dive right into the details. I'm not going to get into too many technical details, just like general details, because if not, we will be here till next week, I guess. But basically, when you're looking at the main challenges that we face, currently all of the environment of Grubhub is deployed on the cloud, basically on AWS mainly. But when I joined the company a bit more than 2 years ago, we were in the middle of transition. Half of our services were still on-prem. And then it created a lot of new technologies and new services while migrating to the cloud from one side. From the other side, you still need to maintain the existing environment on the on-prem area. One of the other things that were there, we called it more like global in the slide, but during the time, Grubhub acquired a few companies. And these few companies came, everybody with his own stack, with his own technologies. We have multiple of programming languages, not only like one or two, like most of the companies that developed everything in-house. Totally different types of infrastructures, from self-managed servers to self-managed Kubernetes to some kind of scaling group in EC2s to EKS, right? Like basically we have it more or less everything these days, which also adding to the complexity here. So I'm trying to figure out like how to present it in the right way.
Let me know. I'll change slides.
Okay. Right. So basically, how you're building AppSec program. Because all of the reasons that I mentioned before, that like many companies was acquired by Grubhub, and not many, but close to 10 during the time. And the migration to the cloud, basically we kind of needed to build all our AppSec from the ground, more or less. So basically it's like the initiation of any AppSec, any other AppSec program, not just the development program. First, you need to learn your new environment, or let's call it in our case, our new environment. And then to make sure that we have the inventory of, like, in this case, it's more like in terms of what type of technologies we have. Less numbers, more like what technologies you need to address. And then basically go ahead with the risk assessment, the scoring for, the business scoring for each one of the services, so each one of the approaches that we had. And from that, basically, we needed to execute a strategy that build our security program and, like, to prioritize everything. And once you know all your needs, the next thing that you need to know is like, okay, I have this and these risks, I have this and these needs, and now how I am going to basically give them the right mitigation and like the most holistic way. Because as we mentioned before, we could basically install a security tool for each type of technology that we had. For example, when we're looking at programming languages and we assessing SaaS tools, most of the tools that existing in the market not going to support Python. Since we have a lot of services that written on Python, most of the security tools, so SaaS security tools, were not going to be good for us. So one of the main things that we did is actually, okay, now let's start to understand exactly how can we find a tool that can cover all the technologies that we have. So looking at it in the more holistic picture, we're not looking only at SaaS, we're looking at all the CI/CD protection, like we talked before, everything that's related to the dependencies, misconfiguration, which can include also the secrets that's existing in the code, and et cetera, and et cetera, and et cetera. Like we can go to infrastructure as code, and basically everything that the CI/CD is covering. And therefore, like one of the things that you look in mainly is like for tools that can give you multi-purposes, let's say this way, can cover many areas as they can, because you cannot now start to install non-stop tools. First of all, most of them are really expensive, and if you're going for the open source way, to manage open source by yourself when you're looking at 6, 7, 8, 9, depend on like, each open source usually have a unique purpose or unique functionality. So to manage and build everything from ground and also keep maintaining these tools, it's something that with the manpower that we have is basically almost impossible.
Okay.
Right, let's move to the next one. Right, like as I said before, you looked for the most holistic tool that we have. And basically what you're trying to do is to create some kind of checklist, what areas you're looking to cover, right? So first, I think that this one is the basic, and this one is like the most traditional one, is like SaaS tool that can cover all the OWASP top 10 vulnerabilities. And then, of course, we have, like we talked before, we have the open source vulnerabilities, libraries that have exposures, the integrity of these libraries to make sure that actually we got the right library, like you mentioned SolarWinds before, and et cetera, and et cetera. Of course, we also have it's part of the OWASP top 10, but usually the SaaS tools are not covering this area. It's the misconfiguration area. And both are applied for infrastructure as code and for the code itself. A part of it, when you're looking at Dockers, there is a lot of misconfiguration that can happen. From simple things like the user that the Docker is running with, and what exactly the areas that like how much intrusive is the access of this container, and how much access we have to this container, what type of packages we are downloading to this container, if we have access to external resources, it doesn't have access to external resources. Like there is a lot of aspects around this world. And this is, I think, one of the main challenges here, actually, to find the right way to scan and to get all the insights that you need to make sure that you're actually securing your environment. And one of the other things that push us to understand that we cannot actually work with multiple different technologies and different tools is the fact that usually our partners, like internally, it's the DevOps team and the dev teams, and they're occupied, like it's really hard to push anything, like even if you have a critical findings, it's really hard to prioritize it with them and to start dealing with them with multiple different reports and multiple different systems that they need to log into and actually verify that they managed to fix the issue or to integrate with multiple different tools. It's something that's going to be impossible. So this is one of the strong points of holistic tool that actually can cover as much area that we can, and like by that we can approach the developers and the DevOps teams and basically showing them how it's becoming very simple when everything is in one place and easy to manage. Right, can we move to the next one? Well, basically when I'm looking at the impact on the business, I don't really have a way to compare the let's say the holistic way to other ways, because we didn't started with the holistic way. We didn't started with a multi-purposes tool, right? So one of the things that I can compare it to is basically the traditional tools that we had, which every one of them have a single purpose, and basically our team, the security team, was running around trying to analyze things, trying to modify the tools, trying to reduce false positives, to understand if we have false negatives, and like every analytics tool that we need to do for security tools. And I think that one of the main things that we gain here is like basically everything is existing in one place, and we can easily choose what to expose to the other teams, what to expose to developers, for example, and what we are still analyzing in offline. Like, I mean, like behind the scene, we have a lot of effort. Like we're scanning everything, we're scanning all the rules, we're not modifying anything. And from that, we're actually analyzing everything and adjusting the tools. And when you're looking at one tool versus 6 or 7 tools, we made our life way easier with a holistic tool. And from the other side, we were in need because of the different technologies that we had, because of the different programming languages that we had, or because of the different stacks that we had, or we still have, actually. We needed sometimes to have different tools for the same purpose. For example, static code analysis, like I mentioned before, we needed at least 2 of them. And this also took a lot of effort and a lot of time from our team, which means that we didn't get the time even to start thinking about implementing other tools that we needed for, especially for the new infrastructure of all the infrastructure as code components and the Kubernetes components. And this why working with holistic tool actually gave us a lot of other abilities that we didn't have before. I can move next. Eran? All right, thanks. Well, kind of few conclusions that we had from all the process. Well, one of the things that we all the time talked about, like that Eran and me talked about till now, is the complexity to actually implement security in sufficient way. We have a lot of challenges, like I mentioned before, the security manpower, the bias from the other teams that we need, the multiple tools that we have, the fact that in the traditional world, we're not covering all the aspects that we actually need. So when we're looking at that, there is a lot of effort that need to be implemented on the security world. And when we're looking at AppSec at whole, I like to divide the AppSec security into 3 different subjects, which one of them is the CI/CD or the supply chain, the service supply chain area, which, for my opinion, or the way I see it, is one of 3. And we have 2 other, basically we have 2 other subjects that as AppSec security you need to cover, or basically it's everything that's related to runtime analyzing and checking. We can make it a bit more simplified by saying like dynamic code analysis, like all the DAS tools, and monitoring tools that actually kind of trying to find the anomalies in the places that you cannot find with static code analysis tools. And from the other side, we have the active protections, which is the third area that we need to deal with. And basically, we can refer this one to the all the network tools that's supposed to detect attacks and prevent attacks, like WAF, for example. If you look more traditionally, like IPS, IDS, and etc. So basically, the CI/CD is one of three subjects. This is what I'm trying to get to. And this subject by its own is really, really complex and and have a lot of complexity. So basically, simplifying it is really crucial things to make in the steps of making the security program work. Because again, in the moment that things are getting complicated, the security team don't have enough resources to actually take over everything. In the moment that you don't have a clear security program and clear security vision, and you don't have a list of specific gaps that you need to close, you can also not get to your partners that actually need to fix it. And again, going back to the DevOps and dev teams. So I think that looking forward, looking ahead, one of the main things, at least I am saying, like the people like that in the world of today, they're not getting enough attention, is like we need to make the things simple as possible, because if not, we will never be able to be in the same speed or the same. We're not going to be quick like the businesses.
Okay. Thank you, Joe. And we're going to have some time for question after the summary. So just to tie everything together and highlight some of the things that Joseph covered. So when we build Argon, we really looked at those two customers, mainly the AppSec team that need to enforce security and make sure that we are releasing a secure application, but also the DevOps and the development organization, that those are the guys that build the code, build those applications, and are responsible for fixing the issues, unless it's a breach or an attack, and then the security team will have to deal with the consequences. So the way that the platform is built is basically we connect to the CI/CD pipeline tools, we do all those analyses, we provide visibility, we provide security enforcement, we provide integrity. But when you think about the next step, the remediation, it is basically done through the standard development process of the organization, meaning that if we found something that is misconfigured, some issues that we want to deal with, the way that the system will deal with is we can do it fully automatically, semi-automatically, or just manual work. We are able, through the system, to send a ticket to the relevant person or owner of this solution or code or file, or we can also open a pull request highlighting the issue, and this way enabling the development organization fix it immediately. And I'll give in a second an example for that. The other side, you have in a minute I'll show you the couple of screens and how it is done. For the AppSec teams, they have the visibility, they have the ability together with the DevOps team to enforce their policy and practices over a large development organization, and getting alerts, and critical one, through Slack, Teams, or any communication channel. So you don't need to sit on the screens and understand what's going on all the time. The system will call you when you are needed. And just to give an example of how we're doing it and why we're getting like a high adoption from the development side, which is very important if you think about the solution securing something that is owned and run and is a crucial part of the development process. So the example is that we have what we call integrity gates. Those are three virtual gates that protect the pipeline, one before you upload anything to the pipeline, the second in the build stage, and the third one after the build stage. So if we take an example of the build stage one, the first one, the pull request gate. So anytime a developer will update a code or a file that has, for example, a secret in it or some vulnerable issue, our system, if it's high or critical, with block, will not allow this to continue, and send a note to the developer saying, hey, you have a secret in this code, please fix it and upload again. So for the developer, basically, he didn't expose anything through the process, uploaded anything to the cloud or whatever the runtime environment is. We basically catching his mistakes very early in the process, notifying him as a comment on the pull request, and he can fix it and upload it again. So training them, reminding them, and basically taking the responsibility of security. So you have someone, a second reviewer of everything the developer will do, that will let them know if something is wrong, and they can immediately fix it. So actually, when we talk to them, they love it. This is basically our unified view. So as a AppSec team, as a DevOps person that connects to the system, you can see all the tools, you can see all the alerts that you have, you can see the score of your all CI/CD pipeline, all your assets, all your top insights and things that you need to deal with. And this enables you in one quick view, understand if you are better or worse than last time you looked at it, and what are the key things that you need to do. And I think this is the first step. If you don't see it, if you're not aware of it, you cannot deal with it, and you are exposed. The second part is really the insight and the AppSec orchestration, and we talked about our ability to enforce and integrate with many tools, and you can see some of our partners here. So basically what we can do, and this is starting to become a trend, and a lot of our customers are asking and implementing that, is that we have the ability to scan all your pipeline files and understand which security scans are actually going to run when you're going to build it. And once we understand that something is missing, we can do two things. We can update you on a report, and there is a port that will tell you in each pipeline, what scanners are running or not. But the system can also, if you can see it on the right or on the left side of the slides, can generate a pull request with a fix to the owner of this specific pipeline file, asking him, hey, you forgot to put like a mandatory step. In this case, it's like a source guard code scan, which is a checkpoint solution. And the developer now understands that he forgot something, he will add it in the right place, and he can release it and upload it. So orchestration is something very important these days, because as Joseph said, a lot of organizations spend a lot of money on various scanners and tools, and we give them a very smart way to enforce them where it means the most, which is the build stage. And the last thing regarding our future capabilities, and I mentioned the SBOM. So not only we secure the whole process, but we have the ability, or before that, we create for each artifact that we are releasing, we are creating a software bomb. So we have all the data about all these components and everything that it contains. Now, if, for example, we found out that in some application we have some vulnerability, this database can help you map it exactly to which Docker container this vulnerability come from. And also you can go one step back and basically check all the other projects that are calling this specific Docker, and make sure that they will not run before you update the Docker and fix it. So really providing you great visibility. And if I want to summarize everything, so I think that what is basically unique about Argon is that we are coming to help you secure the CI/CD pipeline. It's understanding your process and providing you something that is going to be useful for you and can run within your development process. So you will get governance that include unified view, actionable insights, the ability to orchestrate whatever security measures that you want. You will get protection, meaning enforcement of security policies and frameworks over your process, and you decide what process or what policies you want to apply You can decide to dismiss a lot of them, focus on some. We will help you customize and make sure that you're getting the most effective outcome out of it. And at the end, provenance, we will enable you to get full accountability over your artifact and ensure your release integrity by building a manifest that will include all the components of your artifact, but also all the stages that it went through. So we will check if there were 2 reviewers to the code. We will check if there were all the security scan were running on the pull request, on the build, and it will enable you to decide that once this artifact didn't meet all the steps that you wanted, you can move it to manual review, and by that, someone will look at it and take a decision if we want to run it again with a fix or it's okay. Otherwise, if it's all clear, you can upload it to the Artifactory and it will be released. So with that, I will move it back to Julio. If there are any questions, we will be happy to answer. So.
Yes, we have time for a couple of questions here from William. Regarding response to a supply chain attack, how do you determine the balance between rebuilding or cleaning for compromised hosts and credentials? Could you share practices around active monitoring to spot potentially related anomalies?
Okay, I hope I understood the question. So the fixing portion, it's a little bit difficult, and I will explain. For example, we had like the US parser JS vulnerability. So our platform enable you to detect 0-day vulnerabilities in open source packages. So we can identify things that related to attacks against those packages and alert that this is risky and not to use this package because it's a new package. There was changes there that look suspicious. Don't allow it. Now, in terms that we, let's say, find out a vulnerability in a package that you are already using, this is a big question because, I can tell you, okay, this version now, it's super compromised. You need to upgrade to a new version. But this new version can break your build. So you need to work with your R&D team to build the hotfix and test it and make sure that it's really moving to a new package, not going to break anything that you are doing. But the idea here is that in case we see things like code manipulation during the build, like in SolarWind, or pipeline dependencies that is doing something that it shouldn't, like CodeCov, our system can immediately block and fail those build processes if you decide, or send an alert on Slack, on team, to the relevant team to let them know that we see an attack in progress and they need to react quickly.
Excellent. Okay, unfortunately, we are nearly out of time. So if you did have a question, we'll make sure that our speakers get them so they can reach out to you after the webinar. For now, I do want to remind everybody that today's webinar has been recorded. So if you missed any or all of the webinar, you will be able to watch it again. We will be sending an email with a link to access the webinar on demand, and you can also find it at securityboulevard.com. Just look in the on-demand section in the webinars page, and you will find it there. Our 4 Amazon gift card winners today are Troy R. Congratulations. Our second winner is Nancy L. Our third winner is Matt C. And our final winner is Anthony T. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Eran and Joseph, thank you so much for taking the time to put this presentation together and for giving us an hour of your time. We all appreciate it.
Thank you very much. It was great being here, and
pleasure.
we are here if you have any questions.
Of course. And I'd also like to take the time to thank the audience for their time and engagement. This is Julio Godinez signing off until next time. Thank you.
Right. Bye.
Thanks.